Hello and welcome everyone. My name is Mona Yadav and in this video we'll be learning about one more numerical related to viscosity. Now we know that there are various types of conditions in which we can study about the numericals on viscosity. So out of which we'll be solving the numerical based on rotating shafts. So let's read the question. So the question is given as a 15 centimeter diameter vertical cylinder rotates concentrically inside another cylinder of diameter 15.10 centimeter. Both the cylinders are 25 centimeter high. The space between the cylinders is filled with a liquid whose viscosity is unknown. If a torque of 12.0 Newton meter is required to rotate the inner cylinder at 100 rpm, determine the viscosity of the fluid. So the question is given as a 15 centimeter diameter vertical cylinder rotates concentrically inside another cylinder. So basically there are two cylindrical structures. The outer cylinder is having a diameter of 15.10 centimeter, whereas the inner cylinder is having the diameter of 15 centimeter. So 15 centimeter diameter vertical cylinder is rotating inside another cylinder. So both the cylinders are 25 centimeter high. The length of the cylinders is 25 centimeter. The space between the cylinders is filled with liquid. So the gap between these two cylinders is filled with a liquid whose viscosity we have to calculate. So if a torque of 12 Newton meter is required to rotate the inner cylinder. So in order to rotate the inner cylinder, we need the energy, and that energy is nothing but the torque, and that torque is given as 12 Newton meter. So this torque is needed at 100 rpm. So determine the viscosity of the fluid. So let's write down the given conditions. So diameter of inner cylinder is 15 centimeter. Okay, a 15 centimeter diameter vertical cylinder rotates concentrically inside. So this is diameter of inner cylinder as 15 centimeter converted into meters is 0.15 meter. Diameter of outer cylinder as 15.10 centimeter, 0.151 meter. Length of cylinder is 25 centimeter. Both cylinders are 25 centimeter high, means length of cylinder L is 25 centimeter, that is 0.25 meter. Torque T is equals to 12 Newton meter. Speed N is equals to 100 rpm. So let the viscosity of fluid is mu. So tangential velocity of cylinder, we can calculate the tangential velocity of the cylinder, that is u, by the formula u is equals to pi dn by 60. So whenever there is a cylindrical structure which is rotating and we have diameter of that cylindrical structure, also we have the speed in rpm, so we can calculate the tangential velocity by this formula u is equals to pi dn by 60. So putting the value of diameter, the cylinder which is rotating, it is rotating, the cylinder of 15 centimeter diameter is rotating, so that's why pi into 0.15 meter into 100 rpm velocity divided by 60. So we get the value of tangential velocity of cylinder as 0.7854 meter per second. Surface area of cylinder. Now area of cylinder is pi dl. So putting the value as pi into d into l, 0.15 into 0.25 equal to 0.1178 meter square. Now by Newton's law of viscosity, we have tau equal to mu into du by dy. So where du is change of velocity, velocity is u minus 0, u equals to 0.7854 meter per second. Just now we have calculated. And dy is nothing but the gap between these two cylinders, and gap between these two cylinders can be calculated by the diameter of bigger cylinder minus the diameter of inner cylinder, or which is having a lesser diameter. So 0.151 minus 0.150 divided by 2. Now why we need to divide it by 2? Because we just want to have the gap, and this will be on both the sides. Diameter is on both the sides, so that's why we are dividing it by 2 meters. So it is 0.0005 meter. So now putting all these values in, the value of shear stress tau, tau is equals to mu into du equal to 0.7854 and dy equal to 0.0005. So now F, that is shear stress into area, force, shear force is equal to shear stress into area. So the value of shear force will be equal to tau into A. So tau is this mu into 0.7854 divided by 0.0005 into area. Area is 0.1178 meter square. So now why we need to have this? Because we don't have the clear value of tau, but we have area and we can put the value of shear stress here. And we can put the value of shear stress here in the formula of shear force. Now torque has one more formula. Torque is equal to F into d by 2. F is nothing but the force and d by 2 is nothing but the radial distance. So force into radial distance. So this is the formula for torque. Now in the formula of torque we can put the value of torque which is given in the question as 12 Newton meter. Value of F just now that we have seen by putting the value of shear stress as mu into 0.7854 divided by 0.0005 into 0.1178 into d by 2. So d is 0.15 divided by 2. So therefore by simplifying this equation, here we only have mu as unknown. So mu equal to 12.0 into 0.0005 into 2 divided by 0.7854 into 0.1178 into 0.15. So which after simplification the value becomes mu equal to 0.864 Newton second per meter square. So by multiplying it by 10 we get the value in poise. Mu is equals to 8.64 poise. So this is the final answer we get. Now how we have got the final answer, we'll see quickly once again. So basically these were the things which were given to us in the question. We assumed viscosity as mu. Now we calculated first of all tangential velocity by u equals to pi dn by 60. We got this value. Then surface area of the cylinder A is equals to pi dl. We got this value. By Newton's law of viscosity we have tau equals to mu du by dy, but we don't have the value for shear stress. So that was unknown anyhow. So tau is equals to mu into 0.7854 divided by 0.0005. Now we put this value of shear stress in the formula of shear force. So we got this relation, and the value of the shear force that we got previously, we put it in the formula of torque in the place of F. So torque was given in the question. In place of F we put the relation that we got from the shear force, that is mu into 0.7854 divided by 0.0005 into 0.1178 into d by 2. And after simplification we got the final value of mu as 8.64 poise. So this is how the question is solved. Thank you.